This videotape will show you how plane and side milling cutters are used on the horizontal milling machine. In the machine trades, plane and side milling cutters are known as arbor milling cutters. This means that they are driven by a key which connects them to the arbor. After viewing this videotape, you should be able to write down the safety precautions that should be observed in the machine shop and when setting up and using plane and side milling cutters on the horizontal milling machine, identify plane milling cutters and describe the procedures for setting up and using them, and identify side milling cutters and describe the procedures for setting up and using them. Some of the safety precautions to be observed are: always put on your safety glasses, remove rings, watches, and other jewelry, keep sleeves rolled up above the elbows, never use the rapid traverse without first loosening the locking screws on the axis that is being moved, and never leave a running machine unattended. Plane milling cutters, sometimes called slab mills, are used to mill plane surfaces where the width of the work is narrower than the cutter. These milling cutters have a helical design to allow more than one tooth to be in contact with the work surface. This kind of cutting action produces less shock and reduces the tendency for chatter. Plane milling cutters do not have side cutting teeth and should never be used in such side cutting operations as milling shoulders or steps on workpieces. When performing plane milling, the work is usually held in a heavy machine vise, which should be rigidly clamped to the machine table. Since plane milling is usually a top surface operation, the alignment of the vise on the table is not as critical as would be needed to mill steps into the side of a workpiece. Therefore, alignment of the vise can generally be satisfactorily made with a square. When selecting a cutter for a plane milling operation, determine the width of the surface to be machined and choose a cutter that is wider than the surface. The next consideration is the diameter of the milling cutter. Select a cutter with as small a diameter as is practical, because the smaller diameter cutter uses less machining time, making it more efficient. When deciding on the diameter of the cutter to be used, you should take into consideration the amount of material to be removed and the clearance between the arbor support and the vise. The two methods of machining using a plane milling cutter are the conventional milling method and the climb milling method. In conventional milling, sometimes called up milling, the work is fed into the rotating direction of the cutter. This gives the appearance of the work being lifted at the cutting point. In climb milling or down milling, the work is fed with the rotating direction of the cutter, which tends to force the work down into the vise at the cutting point. The problem which may occur with climb milling is that machines not equipped with a backlash device may pull the work into the cutter and cause cutter breakage. In the setup procedure, select an arbor that is long enough to give proper clearance between the arbor support and the vise and loosen all locking devices. Turn on the machine and check the direction of rotation of the spindle. Turn off the machine and clean the spindle hole. Now place the arbor into the spindle hole and pull it into place with the drawbar. To provide the most rigid setup, the cutter should be located as close to the column as the workpiece will permit. Place collars on the arbor so that the cutter can be positioned over the work. Then place the cutter so that it will rotate in the direction for conventional milling. Secure the cutter in place by sliding it over the key in the arbor. Continue adding collars on the arbor until they reach the end of the arbor. Then put on the nut. Tighten the nut so the collars are pulled tightly against the cutter. Place the arbor support on the end of the arbor and position the overarm so that the arbor is seated on the support bearing. Now tighten the overarm locking clamps. The spindle speed for the cutter may be determined by using the formula RPM is equal to cutting speed times 4 divided by the diameter of the cutter. Or it may be determined by using a feed and speed calculator. For this demonstration, we will plain mill aluminum with a high-speed milling cutter. For plain milling aluminum, a cutting foot speed of 500 will be used. For a cutter diameter of 2.5 inches and a cutting foot speed of 500, the calculated spindle RPM would be 725. Set the spindle speed selector on the machine to 810. When using a high-speed cutter for plain milling, the feed per tooth is 10 thousandths. Count the teeth on the cutter and set that number to 810 RPMs on the feed and speed calculator. Now under the 10 thousandths, you can read the feed rate in inches per minute. Set the feed rate on the machine to the closest reading obtained from the speed and feed calculator. You are now ready to pick up the cut on the workpiece. Turn on the machine to start the spindle and notice the direction of rotation of the cutter. Using the vertical table feed, bring the work up slowly to make contact with the cutter. Move the work away from under the cutter and position the table so that the work will be fed into the cutter for conventional or up milling. Raise the table 200 thousandths to take that depth of cut on the workpiece. In plain milling, depths of 100 to 200 thousandths are used for roughing, and depths of 15 to 30 thousandths are used for finishing. Tighten the knee lock and cross slide lock, but keep the longitudinal feet unlocked during this operation. Bring the work up to the cutter by hand to a point where it is almost in contact with the cutter. Now engage the feed and turn on the coolant. Direct the flow of coolant so that it will wash away the chips from the cutter and also keep the workpiece cool during the cutting operation. When the roughing cut is completed, shut off the spindle and use the rapid traverse to move the table back to the starting position. Unlock the knee and move it up for a 20 thousandths finishing cut on the workpiece. Lock the knee and complete the finishing cut on that surface of the workpiece. If that piece is to be squared, turn it so that the machine surface is against the solid jaw of the vise. Seat the work in the vise again and proceed to rough and finish cut the adjacent side. Continue this procedure around the workpiece until it has been squared. Side milling cutters are used to machine steps or grooves in a workpiece. These cutters vary in width from 1/4 inch to 1 inch and come in a wide variety of diameters. The teeth of these cutters are arranged in either the straight or staggered position and are also sharpened on the side. To cut deep slots or grooves, use a staggered tooth side milling cutter. This kind of cutter provides more chip space at higher speeds and feeds than the straight tooth cutter. When cutting slots of over 1 inch wide, 2 or more side milling cutters may be mounted on an arbor together. If 2 slots are to be machined with a ridge left between the slots, a spacer of the exact dimension of the ridge can be placed between 2 cutters to machine the slots simultaneously. To demonstrate the use of the side milling cutter, we will cut a groove in the part that was just machined in the plain milling operation. Use the same procedure to set up the side milling cutter on the milling machine as was used to set up the plain milling cutter. Position the workpiece on the table so that the side milling cutter can be placed on the arbor to give clearance for the arbor support over the vise holding the work. Using the cross feed and longitudinal feed on the table, move the work into position for the cutter to make the desired cut. The cutting foot speed of the metal is 500. By knowing the diameter of the cutter and using the speeds and feeds calculator, the spindle RPM can be determined. Determine the feed rate in inches per minute by counting the number of teeth on the cutter and matching this up with the spindle RPM on the speeds and feeds calculator. It is important to note that on a milling machine, the feed rate is independent of the cutter RPM and must be calculated for a specific cutter RPM. In side milling operations, conventional or up milling is the preferred method. So set up the work to feed into the rotation of the cutter. A good depth of cut for a side milling cutter is between 100 and 200 thousandths. Pick up the cut on top of the work. Move the work from under the cutter and take the depth of cut with a vertical hand feed. Engage the longitudinal power feed. When the first pass through the groove is completed, shut off the spindle and use the rapid traverse to bring the table back to the starting position. Never use the rapid traverse to return the cutter when it is running. This could cause the cutter to dig in and gouge the work. To cut a 1/2 inch deep groove in the workpiece will require 2 roughing passes of about 200 thousandths each and a finishing pass of 100 thousandths in the bottom of the groove. In review, you have seen how to set up plane milling cutters in the horizontal milling machine, the kinds of operations that the plane milling cutter can perform, the 2 types of side milling cutters and how they can be set up in the horizontal milling machine, and the kind of machining that can be done with side milling cutters. The use of plane milling and side milling cutters is very important to the machinist in the manufacture of machine parts on the horizontal milling machine.